Atmospheric pressure, sometimes also called barometric pressure, is the pressure exerted by the weight of air in the atmosphere of Earth. In most circumstances, atmospheric pressure is closely approximated by the hydrostatic pressure caused by the weight of air above the measurement point. On a given plane, low-pressure areas have less atmospheric mass above their location, whereas high-pressure areas have more atmospheric mass above their location. Likewise, as elevation increases, there is less overlying atmospheric mass, so that atmospheric pressure decreases with increasing elevation. On average, a column of air 1 square centimeter in cross-section, measured from sea level to the top of the atmosphere, has a mass of about 1.03 kilograms and weight of about 10.1 n. Standard atmosphere. The standard atmosphere is a unit of pressure equal to 101,325 pascals or 1,013.25 hectopascals or millibars, equivalent to 760 millimeters of mercury, 29.92 INHG, 14.696 psi. Mean sea level pressure. The mean sea level pressure is the atmospheric pressure at sea level or the station pressure adjusted to sea level, assuming that the temperature falls at a lapse rate of 6.5 K per kilometer in the fictive layer of air between the station and sea level. This is the atmospheric pressure normally given in weather reports on radio, television, and newspapers or on the internet. When barometers in the home are set to match the local weather reports, they measure pressure adjusted to sea level, not the actual local atmospheric pressure. The altimeter setting in aviation, set to either QNH or QFE setting, is another atmospheric pressure adjustment. But the methods of making these adjustments are different. QNH is the barometric altimeter setting that causes an altimeter to read airfield elevation above mean sea level when on the airfield. In isotemperature conditions, the altimeter will read altitude above mean sea level in the vicinity of the airfield. QFE is the barometric altimeter setting that causes an altimeter to read 0 when at the reference datum of a particular airfield. In isotemperature conditions, the altimeter will read height above the airfield's runway threshold in the vicinity of the airfield. QFE and QNH are arbitrary Q codes rather than abbreviations, but the mnemonics, nautical height, and field elevation, are often used by pilots to distinguish them. Average sea level pressure is 101.325 kilopascals or 29.92 inches or 760 millimeters of mercury. In aviation weather reports, QNH is transmitted around the world in hectopascals or millibars, except in the United States, Canada, and Colombia, where it is reported in inches of mercury, with record highs close to 1085.0 millibars. The lowest measurable sea level pressure is found at the centers of tropical cyclones and tornadoes, with a record low of 870 millibars. Altitude variation. Pressure varies smoothly from the Earth's surface to the top of the mesosphere. Although the pressure changes with the weather, NASA has averaged the conditions for all parts of the Earth year-round. As altitude increases, atmospheric pressure decreases. One can calculate the atmospheric pressure at a given altitude. Temperature and humidity also affect the atmospheric pressure, and it is necessary to know these to compute an accurate figure. The graph at right was developed for a temperature of 15 degrees Celsius and a relative humidity of 0%. At low altitudes above the sea level, the pressure decreases by about 1.2 kilopascals for every 100 meters. For higher altitudes within the troposphere, the following equation relates atmospheric pressure P to altitude h, where the constant parameters are as described below. Local variation. Atmospheric pressure varies widely on Earth, and these changes are important in studying weather and climate. See pressure system for the effects of air pressure variations on weather. Atmospheric pressure shows a diurnal or semi-diurnal cycle caused by global atmospheric tides. This effect is strongest in tropical zones, with an amplitude of a few millibars, and almost zero in polar areas. These variations have two superimposed cycles, a circadian cycle and semi-circadian cycle. Records. The highest adjusted to sea level barometric pressure ever recorded on Earth was 1085.7 hectopascals measured in Sonsengel, Mongolia on 19 December 2001. The highest adjusted to sea level barometric pressure ever recorded was at Agata, Ivanivsky, Russia, 66 degrees 53 N, 93 degrees 28 E, elevation 261 meters, on 31 December 1968 of 1083.8 hectopascals. The discrimination is due to the problematic assumptions associated with reduction of sea level from high elevations. The Dead Sea, the lowest place on Earth at 425 meters below sea level, has a correspondingly high typical atmospheric pressure of 1065 hectopascals. The lowest non-tornadic atmospheric pressure ever measured was 870 hectopascals, set on 12 October 1979, during Typhoon Tip in the western Pacific Ocean. The measurement was based on an instrumental observation made from a reconnaissance aircraft. Measurement based on depth of water. 1 atmosphere is the pressure caused by the weight of a column of fresh water of approximately 10.3 meters. Thus, a diver 10.3 meters underwater experiences a pressure of about 2 atmospheres. Conversely, 10.3 meters is the maximum height to which water can be raised using suction under standard atmospheric conditions. Low pressures such as natural gas lines are sometimes specified in inches of water, typically written as W.C. or W.G. A typical gas-using residential appliance in the U.S. is rated for a maximum of 14 W.C., which is approximately 35 hectopascals. Similar metric units with a wide variety of names and notation based on millimeters, centimeters or meters are now less commonly used. Boiling point of water. Clean fresh water boils at about 100 degrees Celsius at Earth's standard atmospheric pressure. The boiling point is the temperature at which the vapor pressure is equal to the atmospheric pressure around the water. Because of this, the boiling point of water is lower at lower pressure, and higher at higher pressure. This is why cooking at high elevations requires adjustments to recipes. A rough approximation of elevation can be obtained by measuring the temperature at which water boils. In the mid-19th century, this method was used by explorers. Measurement and maps. An important application of the knowledge that atmospheric pressure varies directly with altitude was in determining the height of hills in mountains thanks to the availability of reliable pressure measurement devices. While in 1774 Maskelyne was confirming Newton's theory of gravitation at Annonshallion in Scotland and accurately measure elevation, William Roy, using barometric pressure, was able to confirm his height determinations, the agreement being to within 1 meter. This was then a useful tool for survey work and map making and long has continued to be useful. It was part of the application of science, which gave practical people the insight that applied science could easily and relatively cheaply be useful.